Welcome to the second session. In this session, I'm just trying to explain how do we use parameter tuning. In order to facilitate better learning, I just created or I am going to create a new R file in order to show you that how do we use parameter tuning. So in this learning, we are trying to create a new R file which is generated out of existing file. For example, the previous file I just named as model building. I'm going to create a new file called as parameter tuning, and I need some more editing. I don't need all the syntax for my parameter tuning. That's the reason what I do. I'm just trying to use some of the syntaxes from the previous one. So let me actually create a new file out of this one and just trying to edit the same for my parameter tuning syntax generation. Let me save the same as a new file. It's called as, let me use it, parameter tuning, and underscore nn. Let me call it as parameter tuning for nn. I just renamed the file as parameter tuning nn. In this algorithm, we have some parameters to tune. Primarily, we want to tune the following parameter. So I'll write down what are the parameters, which I already specified, but still I just repeat what are the parameters we would like to tune in this algorithm. And we have the first parameter called as small letter p. It is called as non-seasonal lags, that is non-seasonal autoregressive component, that is first p. That's the first component we want to tune. And second would be capital P, that is nothing but seasonal lags. Third is size, which is nothing but number of hidden layers. And I told you the rule, while looking at number of hidden layers, there are some recommendation, and it should be less than number of your regressors. Regressors I meant here in this case, we have, let's assume 4 regressor, external regressors, and 2 lags. It would be totally 6 parameters, and the number of hidden layers should be less than that of 6. That's what the recommendation. The last parameter we want to tune is called as decay parameter, which is nothing but how fast you are able to reduce that prior memory or not. This is nothing but what the model will forget with respect to the past. Whether you want to recollect or remember something strongly with respect to the past, or which actually should be weakly forget with respect to the past or not. I mean, in the sense with respect to the learning. So in exponential smoothing, we learned that what extent you are able to use my past or our past information to predict the future. We learned that if that decay parameter is very strong, it explains that we are trying to memorize the past, which is very strong, and if it is decay parameter is weak, it shows that the past may you are not learning anything very strongly. That's what the meaning of decay parameter. Anyway, let us explore in detail. I'll explain this one in detail while building the model. Let's see. Let us proceed with the cross validation. And the first stage of cross validation is that first of all we need to understand what's the concept of cross validation. In case of time series modeling, I have explained it already that cross validation in time series modeling is slightly different from what we do in other modeling. So in this case, we create training and test it and data set, and here training and test selection is not random, rather it will be sequential in nature. I have already explained, therefore I'm not repeating it again. Let us proceed. The first stage of cross validation is in neural network time series forecasting is that first of all we need to create or generate dates column, generate the date, generate the date for cross validation. So what's the time period at which you want to create the cross validation sets? So let me actually create first. I'll explain what's the meaning of each syntax. So I'll first say last date. So let me say last date, which is nothing but I'll create something called as tail. So of my data name is df. So I'm going to use the df data frame. So there is a column here, date, and one that is here. I'll use 30. So let me execute. I'll tell you what is the meaning of tail df date here. So if you see, when I executed last date tail df dollar date 130, it actually created the last date at which you would like to do this forecasting. So because if you look at my df data, so I just want to use my the train data. So if you see my train data consists of day until here, right? So I just want to say that while doing cross validation, I want to use the data until what 2020 December 1st. Okay, that's what the meaning of last date. So let me look at the first date. From where onwards, I just want to create the forecasting date, and that is, I can say tail df dollar date, and I use the first day start with where minus 200. Is it so minus 200? If you execute, you can see, so it means that if you see the first date, so it means that you can choose any date, and what is the starting date at which you would like to actually do cross validation. That is called as first date. A starting date, I just defined that any date which should actually begins, because if you see the first date 2020, it would be June 14th onwards. That's the first date. Is it true? So yeah. So from the tail minus 200 means that would be the date at which you want to start your cross validation. Okay, that's what the meaning. So it is nothing but 2020 June 14th is the date, and we need to first, then while connecting these two dates, I can create the date which is as a sequence of I would say a sequence of vectors. I would say that a seq, that is here, and I can say sequence of date I can create by connecting these two. So I can say in my data frame what could be the ideal date from you can start your cross validation. It could be starting from first date. It could be my first date would be this one, and I can say the two date, two could be your last date. uh, then uh, you can say that how many date sequence you can create. You can say that by week, if you create right now, it created something called as date. If you remember, I just created name of the data is date, and it created something called as date, or you make it for example dates only here, and it created something called as date, and it created date starting from 1 to 25. It means that it created 25. You can type it so that you can see. Look at here. So I just told that please create a data frame or data sequence, I would say, starting from June 14th and to what until 2020 and November 29, right? So that's what I created. If you see here, and here it created 25 different cross validation time periods. Okay, that's what the sole objective of this particular process, right? I believe you got my point what I did actually. So it means that I just want to apply cross validation, so it will apply cross validation mm, uh, starting mm, would be what this period. It should be this period to do the cross validation starting from, and we are creating 25 different cross validation combinations. Okay, so probably you'll understand when I run it afterwards, so that you'll be able to. So then I will create something called as where I want to save the results. I'll create some result vector here, and let me create results vector, and I guess say that results I want to save it in self CV cross validation, save it in a vector of mode is nothing but a kind of numeric, and here I just say that length would be the length of that vector is exactly same as your uh, length of your dates vector. Okay, so that's what I said. If you see the result CV here underscore CV, sorry, spelling mistake, let me correct it. So as of now it's 0 0. How many will be 25 result vectors which we created right now, and that is connecting that. And now probably we can actually mm, generate a cross validation pipeline. So let me create a cross validation pipeline. Okay, now so when we create cross validation pipeline, and it's a pipeline, right? Whatever we did in the past with respect to training, creating training data set, testing data set, and building the model, everything comes in actually this pipeline. Okay, now so just I said it's a pipeline and it's not completed in one single line. So in order to build the pipeline, we actually create some specific stages possibly here. So I'll create first pipeline. May I'll say that for example, so I'll say for J, for example, J here in this case, 1 to length of dates. So here, then I'll create a pipeline. I'm going to build a pipeline here. In this pipeline, this is a pipeline I'm going to build. Here, the first thing in this pipeline, I need to specify what's my training data set, training and test set. Then I need something with respect to creating time series object. Then I need to, I'm just specifying it, I'll type the syntax later. I need to specify here what is getting external regressors, what are the regressors we are using. I'll specify there. I need to specify that your model here, I need to check, or I need to have prediction afterwards. Is it? That's what we did sometime before. And the same thing, I integrate everything here inside. That's what happens here. And then I need to do predictions. I need to check the accuracy at the end of it. That's what the process we did. Everything I'm connecting in this case. Okay, previously what I did here, since part of a pipeline, I just specified these things and I just said that I have 25 different date combinations here, and I just want to create cross validation with respect to that 25 different cross validation date. And here I said all the process I'm repeating: create, training, and test set. That's the first stage, splitting the data into two portions, then making your time series object variable and specifying the regressors which you are using, the four regressors which means, and then you build the model connecting the regressors and the parameters and everything and the data, and then you do prediction based on the model you build, and then you actually create the accuracy. And that's the last stage. Okay, so this is what the stage, and let me actually type what I need to mention it here now. So in this case, I mean, the stages are same as we did actually, but here I just made a pipeline, and but some of these, things are slightly different, and I'll tell you what are the things which is different while making a cross-validation pipeline. And let me actually select the regressors. Regressors is actually exactly same as previous one. Okay, so Let us type actually what are the regressors, which is nothing but in the previous case, which he actually said regressors as training, and I just use the same name actually. I'm creating it again. That's it. Okay, training reg is nothing but as dot metrics. Then we said that it your training data and name all the rows, and column number 3 to column number 6 you just want to use it as what, mm, training reg. Okay, that's what we created sometime with same thing. We also spelling mistake here, training reg. Okay, spelling AINIG, training, and training data we have, so spelling again. Okay, fine. Yeah, so I specify uh, as same. Similarly, your test underscore regress is also same as earlier one. I just make as dot matrix. I say test data. We have all the rows 3 to 6, right? The same thing, right? Since I repeat the process, that's it. So which is same, and I believe time series object is also same as the earlier one. Uh, Let us actually create the time series object, and I have time series object. I mean, same thing which is already created. That's the reason whatever which is same, and I just repeat the process. That's it. So training y, which I already created, I just repeat the same thing. That's it. Okay. TS, or I would say TS here, and then training dollar y. I'm just connecting things. That's it. Okay. Which we already created, and frequency we mentioned that is 7, right? In terms of daily data, I don't need to explain it further. Probably these two things are pretty constant here. Even yeah. So that's it. Okay. So this is same. In case of model, I will use the same model as we did earlier, but I'll change it later. But for the time being, for your understanding, I just copy it and just paste it here in my model. The same thing, I'll do that changes later, but right now I'm just using the default parameters. And with respect to the cross validation uh, date which I specified, that's it. Okay, I won't mention the parameters here as of now. I'll do it later. Okay. So in predictions, we use the same predictions here, the prediction function. I'll use predictions equal to, I'll connect the same thing, forecast. That is a function. So we connect the model which we actually and build. Extract is equal to test data reg. Okay, that's the same thing we connect here as well. Two things will change here. One is accuracy, and accuracy I'll tweak the command a little bit, and also this training and test it will be a little bit different here, because this training and test, especially training test would be with respect to the data dates you created, and I'll change make some tweaking here in terms of connecting the cross validation combinations. Why we need a change in this train and test? Because I have created something called as dates here, right? So I just want to apply the cross validation. While applying cross validation, it's not try to it should be able to capture the dates which you created, your first date and last date. That should be able to inculcate, because usually cross validation will create multiple data combination. The dates created 25 different date combination in order to do cross validation. That training and test set should inculcate this particular dynamism. So that's the objective of changing the test and train set here. Usually while creating training set, I'll type training is equal to, because here I just create out of data frame, I just use percentage greater than percentage. So I just need to filter, and based on date less than or equal to, oh, I just mentioned dates uh, there. I need to put J here, right? J means, dates mean J, or if you change J as 1, you can understand what I meant by, okay? If you see training here, you see here, and if you see the training here, so if you check the new training, you can see that since I specify one here, the first set would be specified, okay, from your dates me. So if you see the first set, what is that? It won't include all the data. It become actually what dates until what the first date as I just specified here, that is 2020 June 14th, right? Is it true? So the right thing would be, it will be make it as J here. In this case, let me create that test. Test is nothing but df percentage greater than percentage. I use a filter which is date is not less than greater than, and dates which I mentioned square bracket j, and I'll mention and date less than or equal to dates square bracket 1 plus 31. So this need to be bracket. We need to add a bracket here. So if I mention 1 here everywhere, and if this is 1, so what we are trying to say, if you consider is 1, you can actually see training date would be from date to the first date. That's what mentioned here. In this case, test date would be what? If you say that if you execute this one, you can see the test date, and 31, is it so? If you see here 15th onwards, right, next 31 days would be assigned like that. Is it true or not? That's what happens here, right? So it means that we are trying to say that if you consider training date as actually the first combination, that is until June 14 2020, that if the training is until June 2020 June 14th, and then test would be next day onwards, that's what is actually assigned. So everywhere you just make it as J, just make it as J, so that automatically the pipeline will build. You make it actually J here, okay, so that things will work in that way. Let me create the accuracy then. So the accuracy would be, we can say that results, because result CV is a data frame in order to store the result we created, and we'll say the result CV J, and we say that and we use the function accuracy, and the function is what we have, something called as prediction, which is created earlier here, which we created earlier here, that is predictions. I just specify prediction here, and the mean of predictions, and test data, I mean you have 5, that would be your predictions. You can say that you just save uh, 1 comma 2 prediction may it will print, because of the previous result may show that will print series of result, right? So it got only one row. The first row may you save only the second one, that is nothing but RMSE. It will save the RMSE out of it, and then I can actually request for printing uh, the dates, uh, you can say J, it actually print all the results from there, okay? So that's what you can do it here. So once you complete all these things, probably you can run it and make sure that you have activated the result vector. It will save the results into your result CV and run the results from here on. Make sure the package is activated and all. Just run it. Still working. Remember, I haven't even specified the cross-validation parameter. I just use the default one. It's working because there are 25 date vectors which I created, and it's working for 25 different date vectors. Me. So it'll take some time. So look at all 25 minutes is trying to run right now. It'll give the results immediately because we don't have the cross-validation combination in the sense parameter combination. It's only date mates. It's working. That's it. Yeah, it's done. Let us see the result CV because which we created a result vector which is created in this case, right? It is trying to print all the RMSE with respect to 25 different combinations, right? That's what happens here. So in order to get the result, usually rather than this is actually based out of the around 25 different date uh, combinations. So here, in order to get the result, we can request here the mean of results CV because it will print actually what's a you know RMSE value which you generated out of this cross validation based out of this default parameter which I applied. Yeah, so I just need to repeat the same process with respect to possible set of parameters, and I do the final parameter tuning, and there I'll specify everything same, but I just copy pasted everything once again. But literally, I just made some tweaking here. I just created something. Here I just use the same last date, first date, dates, and same result vector. And this time I just specify the parameter combinations in form of grid actually. I just specify grid is equal to expand dot grid function. And I specify small b, the possible ranges I'm expecting is here. Capital P, that is seasonal lags, 1, 2, 3, that is first lag, 2, 3, decay is these values, and size is be this. So I specified this one here, the grid made. So if you see grid, you can see the possible combination. These are the possible combinations of the grid here. And now I'll create the result grid, but this time I also club actually with different dates with the respect to this combination as well. So previously I didn't do that. I just want to show you that how a results grid actually look like right now. So if you see results grid with grid, actually you can see and look at the combination. So all the combination 25 date combination terms of tuning, and as well as you have this many grid combination is also there, so that many combination we can expect this year. This time I'm just doing same parameter tuning pipeline, but I just make sure that everywhere I also connect the length with respect to the grid as well. And with that, what I do, same process which I do, I'll repeat the process. And finally, I it will take some time in order to fetch the best parameter, and I'll show you. You can execute this line if you are finding any error. Let's see. Here we connected. Here onwards, you can run and you can run and see. It will take some time because this many parameter you need to tune at least 1 hour to 2 hours time because this many combination of parameter you need to tune. And finally, once you get the parameter, you can get the best grade using this particular function. So that's it actually. Let's see with the results and we'll meet later. Thank you.